Welcome to ZoomInData. Hello everyone. Thank you for joining the Azure Logic Apps series. In this session, titled Serverless Logic Apps at Planet Scale, Extreme Throughput and Cost Engineering, we will cover real-world benchmarks for logic apps handling 10M plus executions per day, 2026 data, advanced serverless scaling patterns, auto-scaling, burst capacity, spot, preemptible instances, extreme cost engineering techniques, reducing bills by 70 to 90% at massive scale, architecture decisions, monitoring at planetary scale, and failure modes at ultra-high volume. Live walkthrough of a simulated high-scale workload plus optimization results. This topic is for architects and teams running mission-critical, ultra-high volume integrations, where every millisecond and every cent matters. If you find this content valuable, please subscribe to ZoomInData and enable notifications to stay updated with the full series. Let us begin. What does planet scale mean for Azure Logic Apps in 2026? Workloads exceeding 10 million executions per day, 300-500 million actions per month. Sub-second latency requirements, P99 less than 500 milliseconds. Zero tolerance for throttling or cold start delays. Cost must remain predictable and under control even at peak. What is the realistic maximum throughput for logic apps today, 2026? Consumption model. Approximately 5-8 million executions per day per workflow. Multi-tenant limit supply. Standard model. 20-50 million executions per day per instance with premium vCPU memory. At planet scale, distribute across 10 to 50 plus standard instances via event grid fan-out. Microsoft guarantees 99.9% SLA at high volume with proper architecture. What are the biggest bottlenecks at extreme scale? Polling triggers, even at 1-minute interval. Millions of wasted executions. Managed connector throttling. Provider side limits. Run history storage I/O. Long retention plus large payloads. Cold starts in bursty workloads. Standard mitigates this. How does the new serverless standard tier change high-scale economics? Preview 2026. Pay-per execution with optional reserved burst capacity. No fixed idle cost, like consumption, but better performance than multi-tenant. Ideal transition for workloads outgrowing consumption but not justifying full standard. What scaling patterns work best for 10M plus executions per day? Event grid fan-out. One event. Multiple logic apps instances. Load balanced. Sharding. Partition by tenant, customer, region. Dedicated workflows per shard. Auto-scaling standard instances via Azure Monitor metrics. CPU greater than 70%. Burst capacity. Spot. Preemptible instances for non-critical peak loads. How do you eliminate polling at planet scale? Mandate webhook. Event grid for all sources. Shopify, Salesforce, IoT Hub. For legacy polling-only sources, use event grid system topics or service bus push. Cost saving. 80 to 95% reduction in trigger executions. Real customer data. What concurrency and batching techniques maximize throughput? For each loops, concurrency 20 to 50. Test to avoid downstream throttling. Batch connector calls. SQL bulk insert. Service bus batch send. Split on triggers to parallelize array payloads. Aggregate outbound messages right pointing arrow single call instead of n calls. How do you minimize storage costs at extreme scale? Retention. 1 to 7 days max. Critical logs to log analytics archive. Payloads. Store in blob. Parse references. Never full content in run history. Stateless workflows for fire and forget. No state tables. Use cool archive tiers for long-term audit logs. How do you use spot preemptible instances for cost savings at scale? Deploy non-critical burst capacity on spot VMs in standard hosting. Azure Monitor auto-scale rules. Switch to spot during low-priority peaks. Fall back to on-demand if spot capacity unavailable. Savings: 60 to 90% on compute for bursty workloads. What monitoring is required at planet scale? Azure Monitor plus Log Analytics, custom KQL for P99 latency, throttling rate, failed runs per hour. Application insights: end-to-end tracing across instances and dependencies. Alerts: greater than 1% failure rate, P99 greater than 500 milliseconds, throttling greater than 5% of calls. Power by Executive Dashboard, cost per day, SLA, throughput. How do you handle connector throttling at massive scale? Replace managed connectors with built-in HTTP plus custom parsing, wherever possible. Implement client-side rate limiting, delay action or queue messages. Shard workloads across multiple Logic Apps instances per connector. Use functions as proxy for throttled APIs with back pressure. What is the role of Azure Front Door or Traffic Manager at scale? Front Door, global load balancing plus WAF for HTTP request triggers. Traffic Manager, route traffic to nearest region for lowest latency. Failover, auto switch to secondary region on outage. Cost, low compared to throughput gains. How do you optimize AI-related costs in high-volume workflows? Cache embeddings, responses in Redis, TTL 24 hours. Use GPT-4o Mini for 80% of calls. Right pointing arrow escalate to GPT-4o only when needed. Batch prompts, multiple items in one call. Monitor token consumption per workflow. Alert on spikes. What is the shard per tenant pattern for multi-tenant scale? One Logic App instance per tenant, customer, or per region. Event grid routes events to correct shard based on tenant ID. Benefits: isolation, independent scaling, easier cost allocation. Drawback: more resources. Right pointing arrow use automation to deploy shards. How do you benchmark and validate performance at planet scale? Azure load testing. Simulate 100 K1M concurrent events. Measure P99 latency, failure rate, cost per 1M executions. Chaos engineering. Inject throttling, network delays. Right pointing arrow verify resilience. Compare before, after each optimization. What cost engineering tricks work at extreme scale? Move non-critical burst to spot, preemptible. Use stateless plus short retention. Replace premium connectors with built-in equivalents. Negotiate enterprise agreements for discounted rates. How do you prevent cascading failures at planet scale? Circuit breakers per downstream service. Track in Redis. Dead letter queues for poison messages. Bulkhead pattern. Isolate tenants, shards. Rate limiting at entry point. API management or front door. What are the latest high-scale enhancements in Logic Apps 2026? Serverless standard tier, pay-per-use plus burst capacity. Higher concurrency limits, 100 plus in for each. Native batch actions for premium connectors. AI-driven auto-optimization suggestions in Azure Advisor. Why is planet-scale knowledge important in interviews? Senior roles ask, how would you handle 20 million executions per day without throttling? Tests understanding of scale limits, cost engineering, and architectural trade-offs. Differentiates architects who think beyond 1,000 executions per day. What final checklist would you recommend for planet-scale Logic Apps? No polling, webhook, event grid only. Standard model plus serverless burst where possible. Idempotency plus circuit breakers everywhere. Short retention plus reference-based payloads. Centralized monitoring plus proactive alerts. Regular load plus chaos testing. Thank you for watching this masterclass on running Azure Logic Apps at planet scale, extreme throughput and cost engineering. If you found this video helpful, please like, share, and subscribe to ZoomInData. More advanced Azure Logic Apps content is coming soon. Stay connected and keep learning. See you in the next video.